about Taylor series solution method to find out the solution of ordinary differential equation numerically, and Picard's successive approximation method to find out the solution of ordinary differential equation numerically. So first we discuss about the theoretical concept of Taylor series solution method, then we discuss about theoretical concept of a Picard successive approximation method, then we solve one numerical example based on a Taylor series solution method and one example based on a Picard successive approximation method. So what's happened in a Taylor series solution method? Taylor's method to find out means a solution of ordinary differential equation. Solution of ordinary differential equation. Ordinary differential equation. Differential equation. Differential equation by Taylor series method. By Taylor methods. So as we know that Taylor method is also a category of a one-step method, means not a multi-step method, single-step method. So what's happened in a Taylor's method, and as we know that all the numerical methods to find out the solution of ordinary and ordinary differential equation, there is a point-wise solution. Means first we find x1, y1 with the help of a x0, y0. Then we find x2, y2 with the help of a x1, y1. And we find xn plus 1, yn plus 1 with the help of xn, yn. Means with the initial condition, means x0, y0, we find x1, y1. Then with the help of x1, y1, we find x2, y2. So graphically, how we show this one? Suppose this one is a x-axis and this is a y-axis, and this one is a initial value x0, and at this value, what is the value of solution? Means y0. And suppose y equals gx be the actual solution. Y equals gx be the actual solution. So to solve any differential equation, first order, first degree differential equation, dy by dx equal fxy, and initial condition is given yx0 equal y0. yx0 equal y0 means dy by dx is a given, and yx0 equal at initial point what is the value for y is a given. So in Taylor methods, we find a one function with the help of our Taylor series expansion, and suppose that function is look like this one. Suppose this one is a y equal fx. This one is a Taylor series expansion. Taylor series about x equal x0. X equal x0. This one is the Taylor series. Now at x equal x1, and suppose these values have equal class interval, means the difference between this is a what? H, means x1 equal x0 plus h. So this one is the value. So at this point, means in a Taylor series expansion, we put x equal what? X equal x1. Once we put x equal x1 in a Taylor series expansion, then we find what? Then we find the value for y1. Then we find the value for y1. Then we find if we denote this one is a Taylor series expansion about x0. Then we find the Taylor series expansion about x equal x1, y1. Suppose this one is a Taylor series expansion, and suppose this one is a what? Y equal f1x. This is a what? This one is a Taylor series about x equal x1. Then in this Taylor series y equal f1x, we put x equal x2. X equal x2 and x2 for equal class interval, this become x0 plus 2h. Then we find what? Then we find the y. Means first we find for initial value, what is a pair of values, means for given x0, what is the value? Y0. Now with the help of this one, what we find, means we find a Taylor series expansion about x equal x0, then putting x equal x1, we find what? x1, y1. Then again we find a Taylor series expansion about x equal x1, then putting x equal x2, we find what? We find next value x2, y2. In a similar manner, what is the last value? Last value is xn plus 1 and yn plus 1. So this one is a what? This one is a geometrical interpretation of a Taylor's method. So now mathematically, how we find a iterative scheme in case of a Taylor's method. So as from the geometrical interpretation, it is clear that we find a Taylor series expansion about x equal x0. So what is the Taylor series expansion? Taylor series expansion. So dy by dx, suppose here mathematical derivation. Mathematical derivation. So what is the ordinary differential equation that we are going to solve? Dy by dx equals fxy, and initial condition is yx0 equal y0. Now first we find the Taylor series expansion about x equal x0. Suppose this one is about y equal fx equal y0 plus x minus x0 y dash 0 plus x minus x0 का whole square, x square of x minus x0 by factorial to y0 double dash and x minus x0 n upon factorial n y0 n, and how many number of terms? Infinite number of terms. So to find out the what? To find out the value of y1, here we put what? Here we put x equal x1. So what is the value of if we put x equal x1? Put x equal x1, then what will happen? We find the value of y equal y1. So this become y1 equal f of x0, this one y0 plus x1 minus x0, y0 dash plus x minus x0 whole square divided by factorial to y0 double dash plus, what is the third term? Third term means the fourth term, x minus x0 power 3 divided by factorial 3 y0 triple dash and so on. So now here in place of x1 minus x0, and what is the value? x1 minus x0. x1 is what? x0 plus h, and x0 plus h minus x0, x1 minus x0 become what? x1 minus x0 become x1 minus x0, x0 plus h minus x0, this become what? This become h. So here y1 become y0 plus x1 minus x0 become h, y0 dash plus h square upon factorial to y0 double dash plus h cube upon factorial 3 y0 triple dash, and so on. And similarly, now we have a what? We have a value of a x1, y1. x1, y1. Here what is the value? Means if we write this one in this form, means a y at x1. x1 is a what? y1. If we write in this form, like an initial condition, means a y x0 equal y0, then y x1 equal y1. Now, we find a Taylor series expansion about x equal x1. Then what is the value? y become y1, y1 means the value of a y at x1, y1, the y0 dash is the value of a y dash at x0, y0, y1 plus x minus x1, y1 dash plus x minus x1 whole square by factorial 2 y1 double dash plus x minus x1 cube divided by factorial 3 y1 triple dash, and so on. Now we put x equal x2 to find out the value of y2. So what's become? This become y2 equals y1 and x2 minus x1. x2 become x0 plus 2a. x1 become what? x1 become x0 plus h. So if we subtract, this become what? This become h. So this become h y1 dash plus h square upon factorial 2 y1 double dash plus h cube upon factorial 3 y1 triple dash, and so on. So if you closely observe these two expressions, means this expression, this expression, this expression, this expression, and this expression, this expression. So this one is to find out the value of a y1, this one is to find out the value of a y2. So in a similar manner, what is the iterative scheme to find out the yn plus 1? Yn plus 1 become what? If we write here, what is the iterative scheme? Iterative scheme become yn plus 1 become yn plus h yn dash plus h square upon factorial 2 yn double dash plus h cube upon factorial 3 yn triple dash, and so on. So this one is a way how we derive the Taylor series solution method. So this was a iterative scheme to solve a numerical problem. What we will do, first we put n equal to 0, then we find y1. Once we find the y1, then find all the derivative at x1, y1, then again we find the value for y2, y3, and so on up to what value is required, means for what value for x the y is required. So in this way we find a pointwise solution. Now we solve a numerical problem based on a Taylor series expansion. So now here one another things that we want to clear, means explain if this one is a given, means dy by dx is a given, means fxy, then means y dash is a given, y dash is a given, f of x and y. So how we find a y double dash? Y double dash means in terms of a partial derivative, this become what? Del f upon del x plus del f upon del y, y dash. So you can also write in this one in this form, y double dash equal fx plus fy in a notational form. This one is a partial derivative with respect to x. This one is a partial derivative with respect to y, y dash. Now similarly, to find out a y triple dash del by del x of y dash means fx plus fy y dash plus del by del y of fx plus fy y dash and y double dash. So this one is so after simplification, so in this way we able to find out what? We able to find out y double dash, y triple dash, y4 dash and yn dash. So how we find a y0 dash? By putting x equal x0, y equal y0. Then we find the value of y0 dash. How we find a y1 dash? By putting x equal x1, y equal y1. Then we find the value for y1 dash. Similarly, y0 double dash. In this expression, which one is a function of x and y, we put x equal x0 and y equal y0. Then we find a y0 double dash. So now we solve a numerical example based on Taylor series methods. What is the example? Means a solve dy by dx equal x plus y, and initial condition is what? y1 equal 0. y1 equal 0. This one is the initial condition. Then solve by Taylor's method and find the value of y 0.1, y 1.1, y 1.1 and y 1.2. So now we solve this one. Solution. How we find the solution of this one? We try to find out the solution of a dy by dx equal x plus y at 1.1 and at 1.2. So by Taylor's iterative schema, by Taylor's method, what is the iterative scheme? Y n plus 1 equal y n plus h, y n dash plus h square upon factorial 2, y n double dash plus h cube upon factorial 3, y n triple dash and so on. So only we consider up to a fourth term. So as the number of a term increases, obviously accuracy also increases. So now if we put n equal to, so there is a need to what? There is a need to find out the value of y dash, y double dash, y triple dash. So what is the given? Y dash is a given in a problem. So dy by dx means a y dash, dy by dx means a y dash is a given. Y dash equal what? Y dash equal x plus y, and y double dash is a what? Del f upon del x. This become what? 1 plus y dash, 1 plus y dash. Y triple dash is a what? Y triple dash is a y double dash, and y4 dash is a y triple dash, and similarly y n dash equal what? Y n minus 1. Y n minus 1. So these are the what? These are the derivatives. Now we put n equal to what? N equal to 0. If n equal to 0, so n equal to 0, then what is the value? y1 become y0 plus h y0 dash plus h square upon factorial 2 y0 double dash plus h cube upon factorial 3 y0 triple dash and so on. So here if we closely observe, so there is a need of a y0 dash, y0 double dash and y0 triple dash. So how we find the value of a y0 dash? y0 dash here by putting x equal x0, what is the value of x0? The value of x0 is a 1 and value of y0 is a 0. And here we assume that there is a need to find out the value of a 1.1 and 1.2. So we assume that what is the value of x? Here we consider h equals 0.1. So here what is the value of y0 dash? Means x equal 1 plus 0. This become what? This become 1. Y double dash 0 equal 1 plus y0 dash. Y0 dash is what? 2. So y triple dash 0 is a what? 2. y04, this one is a what? This one is a 2. So if we consider the h equal 0.1, h equals 0.1, if we consider h equals 0.1, h equals 0.1. So what is the value for y1? y1 means y1 equal y1.1 equal y0. What is the value for y0? 0 plus 0.1 into y0 dash 1 into 1 plus 0.1 divided by 2 y0 double dash into 2 plus 0.1 divided by 2 divided by 6, not a 2, 6 into y0 triple dash, this one also equal to 2. So only we consider up to a 4 term, so this become 0.1, this become plus 0. This one cancel out, this one is again a 0.1, this one is h square, h cube. So 0. Not a 0.1, this one is a 0.01. So 0.1 whole square, this becomes 0.01 plus this one cancel out, this becomes 0.001. So divided by 3. So if we simplify this expression, what is the value? Value become y1.1, y1 equal y1.1. This become, I have already noted down the value of this one, the value of this become what? 0.11033 847. This one is the value of y1. So this one is the value of y1. So what is the value of x1? x1 become 1.1. If we compare like this one, y1 0, then y1.1 is a 0.11033 So this one is the result. Now to find out the value of y1.2, we need to put what? N equal to 1, then y2 equal y1 plus h y1 dash plus h square upon factorial 2 y1 double dash plus h cube upon factorial 3 y1 triple dash and so on. Now we calculate the values of what? Values of y1 dash, y1 dash and y1 double dash. So here if we write what is the value of y1 dash? y1 dash become here we put x equal x1 and y equal y1. What is the value of x1? The value of x1 is a 1.1. 1.1 plus what is the value for y1? y1 is a 0.11033 So rather than to write here, if we write here, what is the value for y1? y1 become 1.1 plus y1 0.11033847. This one is the value. So if we simplify this one, this become what? This become 1.210338847. This is the value for y1 dash. y1 dash. y1 dash. Similarly, what is the y2 dash? y2 dash is a 1 plus y dash. 1 plus y1 dash. So this become 1 plus y1 dash is this one 1.210338847. So if we simplify this one, what is the value? Value become 2.210338847. This is the value of y2 dash. Similarly, y3 dash is a what? y3 dash is a y2 dash. y2 double dash, not a y2, so sorry, y1 double dash, this one is y1 double dash, y1 double dash, y1 double dash, y1 triple dash, y1 triple dash. So y1 triple dash become what? y1 double dash 2.210338847. So now we put the values, these values here. Then we get what? y2 equal y1. What is the value for y1? y1 is 0.11033847. This one is the value for y1. What is the value for h? h is a 0.1 into, what is the value for y1 dash? y1 dash is a 1.210330847 plus h square is 0.1 square by 2 into y1 double dash. y1 double dash is a what? Into 2 point y1 double dash, this is the y1 double dash 2.210338847. Similarly, we write the fourth term after simplification. This one is the value for y2 as well as this one is the y at 1.2. So after simplification, what we get? We get y2 equal y1.2. If we write here, what is the value for y2? y2 become y2 equal y1.2 equal after simplification we get what? We get 2.21033847. This is the value for what? y1.2. This is the value for y1.2. This is the value for y1.2. This is the value for y1. This is the value for y1. This the value for y at 1.1 and the value for y at 1.2. So if we compare this one with the exact solution, so what is the exact solution of this one? So these are the Taylor series solution. So if we solve this one by this differential equation, then dy by dx equal what? X plus y. And if we solve this one, what? This one is the linear differential equation. Dy by dx minus y equal x. What is the integrating factor? Integrating factor become what? E to power minus x. And what is the solution? Initial condition is this one. So y into integrating factor e to power minus x equal integrate x e to power minus x plus a constant of integration. After simplification and putting the value y1 equal to 0, we get what? We get y equal minus x minus 1 plus e to power 2 into x minus 1. This one is the actual solution. This one is the actual solution. So if you put x equal, by actual solution, what is the value? If we put x equal 1.1, then we find what? Y 1.1 equal minus 1.1 minus 1 plus 2 into e to power minus 1.1 minus 1 means 0.1. So if we simplify this one, so what is the result? Result become what? The result become, if we put the value of here, this one is the value 183. And similarly, if you put x equal 1.2 in this expression, then y 1.2 equal, again I have noted down the value of this one 0.24. So here something I think we noted down the wrong one. So what is the value of y 1.2? This one is 0.24. I think this one is the wrong one. So this one is not a correct value. Okay. So what is the value of y 1.2 after? Okay. So after simplification of this one y2, these values, what is the result? Result become what? If we write here, this become what? Y 1.2 equal what? 1.2 equal 0.24 6107. This one is the what? This one is the value at 1.2. So this one is the value at 1.1. This one is the value at 1.2 after simplification of this one. And after solving this differential equation, dy by dx equal x plus y, dy by dx minus y equal x. This one is a linear differential equation. This one is the integrating factor. Then this one is the result. If we put y equal 1.1, then this one is a 0.1103483. And if we put x equal 1.2, 0.242805. 0.242805. This one is the result. So this one is the actual result. Y 1.1. This one is the actual result. So this one is the actual result at 1.1. This one is the approximate result at 1.1. This one is the actual result at 1.2, and this one is the approximate result by Taylor series method at 1.2. So this one is the way, this one is the way how we solve any numerical problem with the help of a Taylor series solution methods. So as we consider more number of terms in a Taylor series, then we get more accurate result.